So the next example is we're going to simulate the Google PageRank algorithm. And before Google, there were many search engines, and they had many ways of picking what pages to show you when you type the running speed of a cheetah, what page is important. And what Google figured out was early on was that instead of just looking at the words on the page, you actually work on the links between the pages. And the PageRank algorithm basically values links. So a page that has a lot of incoming links is valued, but then you have to say, are those links were those like junk links or good links? And so the links that come from better pages are more valuable than links. And so you kind of keep going and going and going. Eventually you get to the whole internet, and it's like, who points to everybody? So this whole PageRank algorithm that sort of has goodness flow throughout the internet. And so we're gonna build that PageRank algorithm. That code's already built, so you don't have to worry about that. But it really takes the goodness of any link, right? If this link is a certain amount of goodness and there's a bunch of outbounds, it shares all of its goodness with its outbound links, and then it takes all the goodness from the inbound links. And at some point you run this over and over and over again, and then at some point the flows stabilize and the amount outbound is equal to the amount inbound. And that's what's called the PageRank. So Google does this right here. I got a picture of maybe 15 little websites as compared to Google doing PageRank on the entire internet. And so we're not going to worry too much about the PageRank. It's really more of a building a web crawler and then running this calculation and then making a pretty picture of the calculation. And so this is basically how search engines work. They really break the task of search engine into three distinct steps. One is crawling the web, which is our gathering phase, and when we're talking about our multi-step data analysis. The next is index building, and that we're going to do, which is the PageRank, which is like sense making of the data that you've crawled. And then searching is looking at the data and figuring out what the right page to show is, but we're not going to do searching in this one. We're going to do visualization and show, when it's all said and done, the results of our index building. And so that's what we're going to do in this case. We're going to web crawl, we're going to index build, and then instead of searching, we're going to do visualization. But you could write, if you wanted to, you could write a search thing that would read the database by the time we've done the index, which is the way a normal browser does it, because we're not really an interactive application class. We're more like doing offline things, so we're going to do visualization instead. So the web crawler is the term we give to this piece of software that gives itself a list of pages to look at, reads those pages, uses something like Beautiful Soup to extract all the links from those pages, adds the links on those pages to a list of links yet to be crawled, and when done, goes and grabs the next page on the list. So there's this building list. Every time you grab a page, it gives you more links. And if you're Google, eventually you've kind of finished. But for our web crawler that's starting like on one page, it would take a very long time and we'd run out of bandwidth and whatever. So we're going to crawl a little corner of the web and stay in that corner. But the idea is have a list of to-be crawled sites, grab one off the top of the list, pull that page down, find all the links, then add those links to the end of the list, and then go back and crawl the next site, and then add those links to the end of the list. And so that's the basic idea of a web crawler. And so we go like that, right? We have a queue, a list of the URLs. We go grab some data, we parse it, find all the links, new links come in, and then we grab one off the top, and we do it, and we do it. And all the while, we're putting all these HTML pages into a database, right? Round and round and round and round we go. And again, it's a really basic kind of thing, and once you did the previous assignment where you use Beautiful Soup to grab the links, the next thing is like, let's go to that next page. So that's what we're going to do. You sort of did that. You had to go like 7 pages or something like that. So things like Google that are doing web crawling seriously, and we of course aren't going to be very serious about it in this class, but you got to prioritize which pages, when to recheck the pages, how often they're changing. You don't want to crush a website. Google shouldn't just kind of beat this website up so badly that your internet service provider gets upset. And then maybe you have lots of different web crawlers. And we're not going to write anything anywhere near as sophisticated as this, but it is something to think about. Also, when you're thinking about crawling, even though the code we do doesn't look for this, there is a way to communicate with web crawlers on websites. If you're building websites, using the concept of a file called robots.txt that you put at the very top. And it's a little specification that basically says, hey, crawlers, go away. Or you are allowed to go here, don't go here, et cetera, et cetera. and it's a very informal and voluntary standard. And I remember when this emerged, web crawlers were just being created, and somebody just wrote something down, and the group of people doing web servers were so small that everybody just agreed to it, and it sort of lived. I think it's a little more formal than it was in the early days, but it's a perfect example of a really simple but good standard that came together really quickly and turned out to be the right solution, and we all just use it. Now, once you have the crawler that's creating all the data in the repository, then you have this thing called the indexer, right, that sort of works on the repository and cleans things up. And then the searching engine gets all this information and then sense makes of it. So search engine indexing sort of pulls the text apart, right? The crawler gives you the text. The search indexer crawls and looks at the text itself, what keywords, what are the words in the links, what URLs it goes to, does this look like it's a spammy page or a bad website, et cetera, et cetera, et cetera. And so it's like actually looking for the useful meaning inside of each of these web pages. And so here's our little crawler, and it's a little more complex than the previous thing that we did. We have basically, again, an application we call spider.py, and we actually input to that a starting point. We say, where do you want to start? Right? So it starts with no web pages to crawl, okay? And then what it does is it goes out and it grabs that page, and back comes a page, and it puts the page in the database, and then it reads all the links, and then it adds empty slots in the database. They're the things that need to be crawled. Then it goes back up to the top of the loop and it grabs the next open one, goes and grabs that page, and then brings that page and adds some text. Reads all the links in there, adds it to the end of the thing. So our queue is actually in the database. We have URLs that we've retrieved, and we have the data for those URLs, and we have URLs that are not yet retrieved. And so we basically do a database query to say what URLs are yet to be retrieved. And so because we're small and we're not Google, this will grow really rapidly, right? We'll have a certain number of pages in there, but our list of unretrieved pages will just go and go and go. And that's why this code stays on what website and doesn't wander off, because if it wandered off, we would never get anything interesting like one page would point to another. It takes a long time to get enough data on the whole internet to make these pictures make sense. So we're going to kind of artificially make web pages that point to each other just so we can play with it. So this database ends up with a list of URLs, some pages, and then some empty, okay? This, again, like all of these pull processes, this can fail. You can stop it with like a Control-C or a Control-Z, or you shut your computer off, and it can be restarted. Because we keep the data on disk, and again, you just blow it up, and then you start it up again. Say, hey, go give me 1,000 more, and then, hey, give me 1,000 more. And so this process sort of just kind of fills. Whenever you want, you can go get more of these things. But at some point, you switch to saying, okay, I got enough. I'm going to do some work. And so the code that does the calculations, so now we got all these pages and some data, and we keep track of who links to who, right? This one links to that one, and that one links to that one, and that one links to that one. And then we keep a page rank, and this is a program called SPRank. It's ranking our spidered web pages. And SPRank actually reads the pages, and then it calculates new page rank, and it's also a loop that's sort of updating the page rank. And so it starts with, you know, this page points to that page, but then it starts going farther and farther and farther to more and more links, and the page rank is being shared with all these pages, right? And so the more times you run this, if you recall, I said at some point all the goodness flows out of all these links, and then goodness from other links flows in, and at some point this number stabilizes, meaning that you can do this and these numbers of PageRank aren't changing, and then you kind of know you've reached the stable point. And so this can run 500 times or 50 times, and at some point the PageRank stabilizes. There's a real simple program called SPReset, which sets all these numbers back to their default so you can start this process again. So this is really very simple. It resets the PageRank to the initial value, and then you run the PageRank thing a whole bunch of times. And so if you imagine what Google is doing, they're doing this all at the same time. You know, it's 2 o'clock in the morning, the servers are bored, So they start pulling more pages in. It's 2 o'clock in the morning, their servers are bored, they just gently, quietly recompute the page rank on all the pages to adjust for the fact that new pages come in. So these are being done continuously inside of Google or any other search engine. For us, we'll do this, then we'll do this for a while, and then we'll say, okay, we got good data and the page rank's been calculated. If you then pull more in, you do have to run PageRank again, so it sort of restabilizes based on the new pages, and you can do that as many times as you want and however much fun you want to do. And then we have some code that could be like the search engine. If we were going to make like an SP search, which you could do, and it could take some characters and whatever, you'd have to write more code. I don't have that code for you. But I have a thing that prints out spdump.py that looks at all the pages and what their current page rank is. Right now all the pages have a page rank of 1. Here's a page rank of 1, and who the friends are, et cetera, et cetera, et cetera. So that sort of prints out kind of like what we do before, just prints a nice text output out. But then, if you run this SP.json, it reads through all the page ranks and then creates some data, again, in the JavaScript format. And if you read this, it's a JSON format. And again, we talked about JSON. And then I've written this, which is an HTML page that uses a visualization system called D3.js. And you can go read up on how the D3 visualization system works. Be thankful that I wrote all that stuff for you. And when this page loads, it pulls all this in and then makes a really cool visualization for you that you can grab and drag. And I'll show you how that all works when I'm showing the example of how all this stuff works. Ultimately, what we have is sort of a more step process where we have a gather process, we have a process to sort of adjust the data, and then we have kind of a dump and visualize process. But we do it all around this one database called spider.sqlite, so we can have all these processes work. Okay? So up next, we're going to come back and talk more about the email data. And now we're going to work on gigabytes of email data rather than a few thousand characters of email data.